Hello, Algebra 2 students. Today we are going to start learning how to graph polynomials. Before we start doing that, we're going to take a look at the parent functions and their end behavior of different types of functions. So first we're going to look at a quadratic. We just spent the last month or so before Christmas and then after Christmas looking at quadratics. So the first thing you see over here is the positive leading coefficient, which means that the number in front of the term with the highest power is positive. Looks like this. Okay. All quadratics share a similar shape. Down here we see end behavior, which is new terms. It says as x goes to negative infinity, which means on the left side of the function, where does y go? And y is pointing up, so y also goes to infinity. As x goes to positive infinity, as we move to the right of our function, y also points towards infinity, meaning up. So some new functions that we haven't graphed. Okay. Well, first let's take a look at the quadratic with a negative leading coefficient. So when the number in front of the x squared is negative, it looks like this. Opens upside down. Notice that both arrows are pointing down. So as x goes to negative infinity, y goes to negative infinity. And as x goes to infinity, y also goes to negative infinity, meaning they both point down. Now let's look at a cubic function. So if the highest term is 3 for the exponent, it looks something like this. Notice this function is degree 3, has 2 terms. On the left side, as x goes to negative infinity, it's pointing down, so y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. Now notice what happens when the leading coefficient is negative. We have left arm up, right arm down. Notice degree 3, there are 2 turns in this function. Now as x goes to negative infinity, y goes to positive infinity. And as x goes to positive infinity, y goes to negative infinity. For a quartic function, so degree 4, should look something like this. Notice degree 4 has 1, 2, 3 turns. Notice that both the arrows are pointing up, so both end behaviors, as x goes to negative or positive infinity, y goes to positive infinity. If you have a negative leading coefficient, takes both arrows, points them down. Now that the arrows are pointing down, both of our y's are going to negative infinity. For an x to the 5th function, degree 5 should have 4 turns. So 1, 2, 3, 4 turns. On the left, y points down towards negative infinity. On the right, y points up towards infinity. If we have a negative leading coefficient, left arm up, right arm down, again 4 turns for degree 5. This time on the left, y goes to positive infinity. On the right, x goes to negative infinity. And finally, a degree 6 should have 5 turns. Looks something like that. As x goes to negative infinity, y goes up on both sides. And then down here, if we have a negative leading coefficient, both arrows are pointing down. So hopefully at this point you're starting to make some conclusions. First, for an even exponent, notice that all the even degreed polynomials have their end behaviors pointing towards the same direction. Both are pointing up, or both are pointing down, depending on positive or negative leading coefficient. For our odd degrees, we either have left arm down, right arm up, or the reverse depending on positive or negative. Okay, the other thing that I keep saying is that if it's a degree 3, there are 2 turns, so one less turn than the degree. So let's take a look at some examples and see how we do. So first thing it says, do we have a positive or negative leading coefficient? This has a positive because it's right arm up, left arm down. This polynomial is degree 3 because there are 2 terms. 1, 2. Since it's degree 3 from our last unit, that means that this is a cubic function. Okay. Now what are the coordinates of our x-intercepts? Looks like -2, 0, and 1, 0. Our domain is all real numbers. Our range is all real numbers. The coordinate of our y-intercept, right here, is 0, 2. Okay, and then we have these new terms right here, maximums and minimums. Another name for a maximum would be the peak or the highest point, and a minimum would be a valley. So the coordinate of our peak up here would be -1, 4, and our minimum or our valley would be -1, 0. Again, revisiting end behavior as x goes to a negative infinity, meaning on the left side, y points down, so y goes to negative infinity. On the right side, our function points up, so y goes to infinity. All right, let's try again. Okay, so positive or negative leading coefficient. This one has negative. Notice that both of our arms are pointing down. Count our number of turns. There are 1, 2, 3 turns, which makes this a degree 4 polynomial, which makes it a quartic. Let's write the coordinates of our x-intercepts. We have -2, 0, and 1, 0. Our domain is all real numbers. And then let's check out our range. This time we have a ceiling. We have a highest point of our function. All of our y values are below that, so y would be less than or equal to 3. Our y-intercept is down here. It looks like we're going to have to guess since it's not an exact value. So 0, let's call that 1/4. And then we'll write the coordinates of our maximum, so our peaks. We've got one here, it looks like -1.5, 3, and one right here. We'll call that 0.75, 0.5. And our minimum right here, which is the same as our y-intercept, 0, 1/4. Let's check out our end behavior. Both of our arrows are pointing down, so as on the left-hand side, as x goes to negative infinity, y goes to negative infinity. On the right, as x goes to infinity, y also goes to negative infinity. Okay, so one more. Alright, so positive or negative leading coefficient. Notice that both arms are pointing down, so this is a negative leading coefficient. This is a degree 2, since there's only one turn. That makes it a quadratic. For our x-intercepts, notice this quadratic does not cross the x-axis, so the answer here would be none. The domain is all real numbers. Range, y is less than or equal to -2. Our y-intercept would be at 0, -3. Our maximum at 1, -2. There is no minimum value. And since both of the arrows are pointing down on the left and the right, as x goes to negative infinity, y goes to negative infinity on both sides. Thanks for watching the videos.